Bismillahirrahmanirrahim. In task 3, I would like to present a solving non-problem, which is the river crossing problem. For my biodata, my name is Muhammad Atib Amrin from Unit PPSMP 25/13 Mathematics SK2. In subject MTSS 1142 Computational Thinking, to by lecturer name Sir Benny Kong TZ. What is the non-routine problem? A non-routine problem refers to a problem that has no immediately obvious method. It requires creative thinking, reasoning, and several strategies to solve it. Unlike a normal problem, which it uses a less thinking and less method. Here we can see the non-problem problem, which the farmer must cross river by a small boat with his assets, which are the wolf, the goat, the basket of cabbage. The constraints wolf and goat is unsafe, goat and cabbage unsafe. Farmer must avoid dangerous pet, which he must avoid wolf and goat as well as goat and cabbage. The boat can carry the farmer and one asset only. As we all know, the Polya model introduced by George Polya in 1945 in his seminal work. Step 1, understand the problem. Step 2, devise a plan. Step 3, carry out the plan. Step 4, check the solution and expand. In solution 1, which is traditional, I'm use a systematic trial, which I assume that step 1 and step 2 using a computational thinking with decomposition and pattern recognition. Where step 1, I will be breaking down the problem by parts and assume that a farmer, wolf, goat, and cabbage with the entities F, W, G, and C begin all on left bank, all on right bank. W and G or G and C are unsafe, which we call it the dangerous pair. And how about step 2? I'm use a step exploration where I list all assets, check safety between left bank and right bank, which all trips God described as K recurring here because God state as a conflicts. God move first and last. Wolf taken in tip three. In trip three. Here I'm check out the strategy where I'm use this strategy for 7 trip, where the wolf is taken in step 3, and we know that the god is recurring as K here, so I'm take the god first, and the lastly farmer and god across, which I'm take the god in the last trip, where the goal is achieved here, and the problem is valid in this strategy. Here in step 4, I assume that goal state achieved, where all entities on the right side are better recognized, where the god recurring as a key here, where he has a conflict with cabbage and wolf. And the lastly, no forbidden state, where there are no dangerous pair during the trips. I am sure that solution 2 is a new strategy where I'm use a constraint analysis, where in step 1 I'm use expression, where I'm use the notation system, where I state a notation system in all entities, banks, where it's easier to solve the problem. How about the step 2? I'm use a algorithm design, where I'm use constraint analysis by following the rule of algorithm. Uh, Step 1, code take in first crossing. Step 2, always check on remaining left, where step 4, return with resolve conflict entity. Step 5, never let WG or GC alone, because this board has a conflict pair. Step 6, algorithm decision and when goal is achieved, where all entities on the right side. Here I'm use the constraint analysis that followed by algorithm rule, where the garbage is taken in trait 3, but it has a different solution here from the solution 1, where uh, the garbage and the wolf in trait 3. But this word solution has a validity, which here proof there is another way to solve this problem. Here in step 4, goal state achieved where the all entities here on the right side. All algorithm rules followed by using a constraint analysis. Five step of all algorithm rules is followed here. And lastly, no forbidden state where there is no dangerous pair here, which goat and wolf or goat and cabbage. Here I made a comparison between both solutions in several aspects where computational thinking approach work path, number of tricks, validity, accessibility, creativity. And as we all know that solution 1 is different from solution 2, where solution 1 I am apply I am applying deep composition and recognition, while abstraction and algorithm design for solution 2. From the level of approach, it's I'm use a concept of trial and error, and solution two based on constraint analysis that designed by algorithm. Workpack, as I say in previous slide, I thought I say that wolf in T3 for solution 1 and cabbage in T3 for solution 2. And we know as we all know that both solution has a validity and accessibility for solution 1 is more intuitive, which is easier for a beginner to use this strategy for solution 1. How about solution 2? Solution 2 must more systematic, where it use a lot of creativity and critical thinking to solve this problem. How about creativity? Creativity for solution 1 is medium, which is less logical reasoning and less thinking. And how about solution 2? High thinking, which it use a lot of creativity, and we must use a logical reasoning for solving this problem. In conclusion, as we all know, Polias model helps students to do framework in an easy way, which each developed student to make a several plan to solve this problem. How about second, both solution confirming that seven trips is minimum, but solution two is more creative. Uh, Three, besides solution one, there is another valid way to solve this non-routine problem, which is solution two. We use a constraint analysis, which includes our creativity and high thinking logical reasoning. Lastly, algorithm design provides a rule-based which avoids forbidden state. So, by using the constraint analysis, we can avoid the forbidden state, which is the dangerous pair.